what we're going to be talking about today. Well, let's use just a simple example, water. Okay. So when you look at your periodic table, hydrogen, how many valence electrons does it have? One. So what's its oxidation number? Plus one. What about oxygen? How many valence electrons? 6. Giving it a oxidation number of -2. Okay? So we have hydrogen, which has 1 extra electron, and oxygen, which is missing 2 electrons to be stable. Hello? Yeah, he came in late. So hydrogen and oxygen will form compounds. They can sort of work together to make each other stable. Okay? Each hydrogen, which has that 1 extra electron, will share it with oxygen. So they have those sort of in common. Yeah, and then another hydrogen will share its electron with oxygen. So it's like oxygen is gaining the 2 that it was missing, and it's like the hydrogens are getting rid of the 1 that they had extra. And so all 3 atoms are then stable and happy, and they form a compound, and they bond together. Okay? Now, we use what we call the crisscross method to predict this. So what you do is you write, for this one, we have hydrogen, which is +1, oxygen is -2, balance them all out, we end up with a 0. And so we use this crisscross method. What we do, first, we write down the oxidation numbers. Now we're going to talk about metals and nonmetals today, but metals are usually on the left, nonmetals on the right. So hydrogen is considered a metal, oxygen is considered a nonmetal. Okay. We write the oxidation numbers for each of them. Above them, hydrogen is +1, oxygen is -2. Then we do this little crisscross thing. We forget about the sign, and we take the 1 and put it as a subscript for the oxygen. We take the 2 and make that the subscript of the hydrogen. Okay. And then we have the formula, H2O1, but in general chemistry conventions, we don't write the 1 as a subscript, so we just have H2O. Okay? Let's look at some more examples. Sodium, a metal, phosphorus is a nonmetal. We write the symbols for each. Sodium is Na, phosphorus is P. What's sodium's oxidation number? +1. Has 1 valence electrons, +1. How about phosphorus?
5.
Not 5. It has 5 valence electrons.
-3.
It's -3. So when sodium and phosphorus form a compound, Na3P. No, because and that should make sense. Why? What are metals looking to do? What is to become stable? The metals are on the left. They're things with a positive oxidation number. What do they want to do with those electrons? Get rid of them. So 2 metals are both trying to do the same thing, trying to get rid of their electrons. Therefore, they're not going to fulfill each other's needs. They're not going to make each other happy and be a stable couple. Okay? They need to look elsewhere for that. Calcium and sulfur. Calcium. What is its oxidation number?
2.
So Sulfur. Right?
It don't make sense.
Okay. And we can simplify as well here. Because they're both 2, we can simplify that to CA. Because we're looking at the proportions.
What about the 2 though?
What's that?
Like
They both have 2.
They both have 2, so we're simplifying.
Oh.
Duh. It's like fractions.
All right, you go ahead and do these 3.
Rats.
Really early. Is chlorine a metal?
All right. Beryllium and fluorine. What's beryllium's oxidation number? Raymond? Fluorine? Go on. -1. Formula for the compound? Donovan?
BEF2.
BE.
VE capital.
Any questions? Got it?
Yes.
Magnesium and oxygen. Magnesium's oxidation number.
That's 2.
Raise your hand. Magnesium's oxidation number, Mian.
+2.
Oxygen. Chippy? Okay, what do you get for a formula for the compound? Somebody else? Maureen? Mg2O2.
Or MgO.
Or we could simplify that MgO. Did you forget that other two? Okay. Alright, barium and chlorine. Barium's oxidation number. Tanya?
We don't have that.
Oh, we have a different one?
Yeah, we have a different
Calcium
one.
and sulfur
We have
again.
calcium and sulfur.
Oh. Let's do beryllium and chlorine as well. Barium and chlorine. What's barium? Check it out.
+2.
Chlorine.
-1.
So it's
BACL2.
BACL2.
In my head.
Alright.
same here.
So easy, got it? Anybody have a question?
Back over 2.
Just thought I'd add that.
All right, last slide. Let's talk about metals versus non-metals.
Let's.
So, metals and non-metals are divided up on the periodic table. Okay. Metals are on what side?
Left.
Left. Non-metals on the right. And so, what's the difference between a metal and a non-metal? Anyone have any ideas?
One is gas.
Which is a gas?
Sulfur isn't gas.
It can be.
Yeah, it can
Oh.
be.
Well, that's not.
All elements can exist in all three states of matter. So it's not liquid, solid, gas. What do you know about metals properties versus non-metals? Can be. Metals can be magnetic. What else can metals do that non-metals cannot? They can conduct electricity. They conduct heat.
Smart.
Okay. So, metals are elements with less than 4 electrons in their outermost shell. Non-metals are what?
Ones that have 4 or more.
No,
5.
Why? But then what?
more than 4.
What has
We'll
4?
get there. We'll get there.
Okay.
So, metals have less than 4 electrons in their outer shell. Non-metals have more than 4. Metals want to lose those extra electrons. Non-metals, what do they want? What's that? Yeah, they want to gain electrons to fill up that outermost shell. Metals have positive oxidation numbers. Non-metals have
Negative.
negative oxidation numbers. Finally, metals are malleable and ductile. Anyone know what either of those words mean?
Never mind.
Malleable, mallet,
Oh! You could smash
Maya? What?
Smash it.
Well, anything is smashable,
They hurt.
but when you smash them,
They
They
break.
can like change shape and.
they can change shape. You can hammer it into a very thin shape. Okay? Ductile. Ductile
Like
You
duct
can
tape?
can be drawn out
Like duct tape?
into a wire. Okay?
Or like aluminum?
Like many, all metals.
It's like aluminum.
All right. Non-metals, however, cannot. They are brittle. They will generally break. Okay?
I went to MCC once and they were doing the same with like they were ripping apart like slabs of metal
Yeah.
and like they would heat it up and then they would just go like this like T-bucks in the dirt.
Oh, stretch it out?
Yeah.
Yeah, that's because it's ductile.
They got like
Be drawn into a wire. All right. Usually, metals link up with non-metals to form compounds because they can both match up. One wants to get rid of electrons, one wants to gain electrons.
So what happens when you mix them? Is it like somewhat brittle, somewhat malleable, and
So we have some elements that are sort of in between. We call these the metalloids. They have some properties of metals and non-metals, and they can change properties. These are found along the stair step in your periodic table. Now, the stair step
Magical lines.
divides metals, non-metals, and
Oh, I
shows
know
the
what it
metalloids. Where
Like
do you
this.
think the stair step lies?
Boron. Right here.
Metals are here, non-metals are here. Okay, that's sort of the dividing line, more or
Oh, there's
less.
a lot more metals.
Okay? Yes.
What do
Right.
they mean by like non-metals?
They're not metal?
It's just another
What's the
sort of
stuff at the
category.
bottom?
Those
Oh, that's
are,
just- they don't have enough.
those are just inserted in there because if they were all here, then the periodic table would be this wide. Okay? And many of these are man-made elements. Hello?
Make an element.
What's, there's only 1, 2, 3,
So
4,
you
5,
can just,
6,
like, make
7
metal
miles.
You don't need a permit.
There's only 7
Okay.
miles.
This is the dividing line. Non-metals on one side, metals on the other, and metalloids are pretty much in the middle. All right, any questions?
Are we supposed to draw this?
Yeah, sure, draw it in.